Well, hello there. I didn't see you come in. Just kidding. Today we're going to work on section 7.5 systems of inequalities. Remember the inequalities, the little alligator or Pac-Man, whatever? We're going to do that. Students will learn how to solve systems of inequalities by graphing. Determine the systems of inequality when given a graph. All right, pencils down. Let me show you everything and then I'll quickly read it. So this should all be review right here. The solution set of a linear inequality in two variables is a set of all solutions. So if you look at the graph, everything that's in the colored stuff, including the line, is a solution or a possible solution. So an example of this would be the inequality x plus 2y is less than or equal to 8. And the shaded region. The solution set is half a plane, so the plane would be the stuff that's being colored in. It consists of the line x plus 2y is less than or equal to 8 because we have a solid line and all the points below it and to the left. The line is called the boundary line. All right, this is also review. Okay, so if the inequality is less than or equal to or greater than or equal to, remember you're going to have a solid line and you would have something like what I have here with the graph. You would graph this. So the easiest way here would possibly be by changing the inequality into slope-intercept form and then graphing and then shading. So the reason, if you notice here, the reason why you see the other inequality is because it turned out to be false when we use the test point. The easiest test point to use, something to keep in mind or remember, would be 0, 0 if it's not going through the boundary line. If the inequality is less than or greater than, the boundary line is going to be dotted. And then an example of this will be x plus y is less than 2. As you see there, including the shading. So again, if it ends up being true, if the statement ends up being true when you substitute the test point, then you're going to shade towards the test point. If it's false, you're going to shade away from the test point. All right. Make sure you copy this part right here. To graph the solution set of the inequality, graph the boundary line. Select the test point. Again, the easiest test point to use will be that 0, 0 if it's not going through the boundary line. And determine if it's a solution. Shade the half plane. Okay, we have something that looks like this, and you want to determine a couple of things. Your slope, remember your slope is going to be in front of your x, so it's going to be up 1 and to the right 2, and your y-intercept, all right? So make sure that you have your y-intercept. There's your y-axis, the x-axis, and let's go ahead and graph that. Then you also want to determine if this line is going to be solid or dotted or broken. In this case, it'll be broken because we don't have that inequality symbol. So let's go ahead and graph that. Now, you want to go ahead and use your test point for this to determine where you're going to shade. So again, the test point, because we notice that the line does not go through 0, 0, I'm able to use it. So x and y. Go ahead and substitute in. This would be 0 is less than 1/2 times x, which is 0, minus 3. So here, you need to determine if this is true or false. Is -3 bigger than 0? I'm going to go with nope. So, because this is technically false, we're going to shade away from our test point. So this was false, shade away from the test point. All right, now we're going to go ahead and graph the bottom inequality. Our slope is going to be a -1 over 1 and, that -1 over 1. And then my y-intercept is at 2. All right, and then we need to determine if our line's going to be solid or broken. In this case, it will be solid. And then we're going to go ahead and use our lovely test point. Again, I notice that it does not go through 0, 0, so I'm welcome to use that now. So 0 is greater than or equal to a -0 plus 2. And then determine if this is a true or a false statement. So true or false, this would be false because 0 is not bigger than 2. So again, you're going to shade away from the test point. So you would not shade this part. You're going to shade the other side. like that. And what you're really looking for is the intersection. So it would be all of this right in here. All right, that was example uno. Let's move on and try another. Sometimes you're going to have more than two inequalities. So in this case, we have three. Go ahead and start graphing them. Remember what we have here, that x is less than or equal to 6. That is going to be a vertical line at 6. All right, so make sure you get it in there. Sorry, I'm way ahead of you. And then make sure that you pay attention to your slope here. Your slope is 1/2 here. So you're going to go up 1 and to the right 2, which is what's being represented by this red line. And the purple line is what I have here for y is greater than or equal to a -2 plus x plus, sorry, a -2x plus 4. Okay, and then you're looking for the overlap. All right, so again, notice that none of these lines went through 0, 0. So for all of these, I'm able to use that 0, 0 in order to determine where I'm going to shade. And where all three overlap, that is your solution. In this case, our solution was right in here where this triangle's already at. All right. All right, let's try another. Okay, so very similar as the one before. So here we're looking for our slope. Our slope is going to be 1/1. And then my y-intercept is at -1. For that inequality, it's already in slope-intercept form, which is great. And I'm going to go ahead and graph it. And I need to determine if this is going to be a solid or a broken line. Should be broken because we do not have that equal sign underneath it. So at -1, there it is. And then up 1/1, up 1/1, etc., right? So then I should have a broken line like we had mentioned. It should look something like that, right? Boop, 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 boop. Okay, I'm going to quickly check my test point to see where I'm going to shade. So 0, 0. So this would be 0, and then 0 is greater than a -1 when I substitute in. That, sorry, 0 is less than a -1. Is that a true statement or a false statement? 0 is less than a -1. That's going to be false. So we're going to shade away. So I'm just going to put the arrows here to indicate that I would be shading that way. Okay? Away from that test point. Now, if I look at the next inequality, I have a -x² plus y is greater than 2. What I'm going to do is have the y absolutely by itself because this is technically a quadratic. So I should see a parabola. So this is going to be y is greater than x² plus 2. I'm going to go ahead and find the vertex. Just in case you don't remember how to find a vertex, it is x equals a -b over 2a. And remember from standard form of a parabola, ax² plus bx plus c. That's where it's coming from. So we technically don't have a b term, so that's where I'm getting the 0 from. So that's going to be 0 there for x. Substituting back in, this is going to be y is greater than 0² plus 2. So here we're going to have y is 2 technically, right? So I'm going to find that vertex at 0, 2, which is over here. And because my a value is positive, I know my parabola is going to shoot up. So it should look something like that. So I'm going to go ahead and make a generic parabola like that. Oh, my mistake. This parabola needs to be broken. So let me do an overlap here. Broken, broken, broken. Make sure it's all broken. Don't be like the Lopez. Broken, broken. Okay. Make sure that's broken. Now we're going to go ahead and check the test point. We also notice that the parabola does not go through 0, 0. I'm going to use that as a test point again. All right, so I'm going to go ahead and pop it into here. So using that test point of 0, 0, this is going to be 0 is greater than 0 plus 2. 0 is greater than 2. Is that a true statement or a false statement? Is 0 greater than 2? All right, so this would be a false statement. Wait. Since it's false, we're shading away from the test point. So technically, we'll be shading here. Now, technically, there is a point of intersection. Although our graph isn't big enough, it doesn't show that there are intersections. But somewhere out there in infinity land, both the parabola and this line would intersect. It would look, let me give you something like that. It would look, sorry, again, it should have been broken. It should have looked something like that. Okay, as we keep going towards infinity. And yes, there would be an overlap somewhere around here. Okay, let's pretend that's our x and y. Okay, so that's technically what it would look like. All right, guys, we're all done for today.